Hello, good evening. I'm Yogendra Kumar, mathematics teacher at askIITians. Okay, today we are going to do lecture number 3 on probability, which we discussed already that it comes for 4 marks. It is really important chapter and easy chapter to understand. You can score full marks in this chapter easily. So let's get started. Okay, we have to cover these topics today, which are the last topics on this chapter. Okay, compound events and geometrical probabilities, right? How do we find out geometrical probabilities? By the way, compound events we have discussed before also. If we are selecting more than one, okay, if I need to define it, okay, so we can write down here this compound event. In short, event that has more than one outcomes, right? So let me write it in proper. Okay, event which has more than one outcome. Those events which has more than one outcome. Event that has more than one sample point. Okay. Now what is sample point? Outcome point. Okay. Or the event which has more than one outcome from the sample space. More than one outcome from sample space, right? This is what it is, right? This is what we need to remember. Now geometrical probability is what something like we want to deal with. Okay, like suppose I say there is a circle of radius r and I want to choose a particular point, right? Suppose there is a circle of radius r and I want to choose a particular point from the plane of this circle, okay, here, and that point belongs to this sector, one of the quarter of the like this, okay, one particular quarter or like that, okay, we can say. So if it belongs to this, right, from this shaded part it is chosen. So what is the probability? So we say here probability of that will be what? Shaded area, means that area which is what, 1 by 4 of pi r square divided by pi r square. So this is going to be 1 by 4. This is what geometrical probability, simple, right? So now how do we, like when we have more, like infinitely many outcomes, right? When we have many, if I'm talking about points here, so I have thousands of points, okay, in this plane. So this time, like we cannot exactly write down the number of the points here divided by total number of points, okay, like this. So let's understand this further, right? First compound event is clear. I think this is pretty easy. Contrary to simple point event, okay, if any event consists more than one single point, right, more than one single point of the sample space, such events are called as compound event, right? Example, if S is what, this one, like this is the sample space, so we are choosing an event which is having 56 and 54 out of this sample space. So that is what our compound event, because it has more than one sample point, right? E1 and E2 represents two compound events, right? This is what it is there. So now, okay, if one roll uh, a four-sided die, okay, if I roll, my bad, okay, if I roll a four-sided die and a six-sided die, what is the probability that four-sided die and six-sided die, what is the probability that they will both show the same number, right? They will both show the same number. So show the number one, sorry, they will both show the number one. Okay, this is what, like weird format of the question. Okay, don't get confused by the question. I know, like we can have so many other questions. Okay, like if suppose two dice are there and we want to, they shows the, like, okay, I can take the example, another example. Let me say, okay, like I know this wording of this question is like weird, they formed, okay, like this here, four-sided figure and all, okay, like We need to remember this die only, don't get confused. Okay, so suppose two dice are there. Okay, we are rolling and we want to find out the number. They show the same number on the, or like they will show the 1 1, right? Both will show the 1 1. Okay, so here both are showing 1 1, so we will say that is one outcome, right? 1 divided by what? Okay, total cases will be what? 6 into 4, so it should be 24. If they, this is what correctly they said, 4-sided die is there and 6-sided, so that's why total n of s will be what? 6 into 4, which is what? 24. And 1 1 they shows means 1 on the first die and 1 on the second die, so that is what? 1 divided by 24 here, right? This is how we can answer this. Simple, right? This is what the answer we are getting. Suppose question is what? Okay, two dice are there. Okay, let me make it a better question. I think we can say example is what? Two dice we are throwing and we want to show 1 1 on both the dice, so that is what? 1 divided by 6 into 6, so that will be what? 1 by 36, right? This is what probability of that event, like this. Now, is it a compound event? No. Showing 1 1 on both the dice is what? 1 1 only, right? From the sample space, so that is just one a simple event. It is not compound event, right? So let's see. Now, geometrical is what main thing we want to cover in this lecture. Okay, so geometrical probability, as I told you before, is a tool to deal with the problems of infinite outcomes, right? Like the way I said, in a circle we have infinitely many points. So listing out, if I need to find out the probability of listing out that, okay, so I don't know number of like it's infinite, it's like huge, right? So that's why we need to take the area into the consideration, or volume in 3D shape. We will take the volume, but in 2D we are going to see the area, right? If it is volume, right, okay, we will take the area. Sorry, if it is 3D we will take the volume, right? Dealing with continuous variables can be tricky, but geometrical probability is a powerful or useful approach to perform the probability on the on these type of problems, right? So let's see, right? Let's see the questions. Okay, fine. This is also like a practical scenario. Okay, we can see like, okay, your bus is coming at a random time between, okay, random time. Bus timing is not fixed, but you know that it is about 12 p.m. to 1 p.m. and you shows up there at you show up at the 12:30, right? You are there at 12:30. So what are the chances that you will miss the bus or you will catch the bus? Now bus is coming anytime between 12 to 1 p.m., right? So now here you are exactly in the middle, right? So 50% chances are there, because 50% you can miss, 50% you can catch, like that. Okay, so it should be 1 by 2. Probability should be 1 by 2. So like this we give, okay, 50% chances are there that you can miss or you can catch the bus, right? Because it is evenly, we are considering that bus timing is what? Evenly distributed. Like we need to understand this, right? So this is how you answer in this scenario, because it is like there is not exact number or like that we can put here, right? I hope you got the idea. Okay, yes, that is what it is, right? This is what I explained here. Missing bus 30 or catching the bus 30. Okay, you can interchange here, catching the bus and missing the bus. Okay, like that it could be. Okay, let's do this question. This is what, like, more questions on this, like, yeah, geometrical probability and all. I showed you the one of the example there before also. So now here they say a jar has 20 red jelly beans and 5 green ones, right? So jar is having, mm, let's see, this is a jar, 20 red and 5 green, right? I pick 2 jelly beans. I pick 2 jelly beans. What is the probability that they are both green, right? We are picking 2 jelly beans, and what is the probability that both are green? Okay, so first one is green, right? Second one is also green, right? So what is it here? Like what should we write here? So what should we write here? First one, first jelly, first Jelly bean is what I'm picking out. Okay, jelly bean. So first one I pick, that is also green. So that is 5 by 25. And then second one is also, right? So 5 by 25. So what is the answer here? 1 by 5 into 1 by 5. So it is what here? 1 by 25. This is how we need to answer it, right? I hope you got it right. This is what, okay, 1 by 30. Okay, we can check this. Okay, 1 by 30 is the answer given. Okay, so how do we, okay, I think we should do it by sample space then. Okay, like this question. Okay, see, if they are like, okay, this question answer could be this also if I'm picking one after the other, but that is not mentioned in the question, right? This answer could be also there, one after the other. First jelly bean I'm picking and second jelly bean, but that is not mentioned in the question, so that is doubtful, right? It could be like in any order. Okay, let me write down the sample space for this, right? Sample space would be what? Okay, for this case, first jelly bean could be like, we are picking up two jelly beans, so it should be red. It could be red, green, it could be, okay, red, green. So how should we do it? Okay, like this is what it is here. Okay, it should be like, okay, what is the probability that they are both green? Okay, both we want to be, we want to make them green, right? So what it should be? Okay, we should mention here. Okay, I think we need to correct the answer here. Let me change the here. It is like 1 by 25 should be the answer, but yeah, let me make it, because this type of questions later on when you learn permutation and combination next year, you're going to learn. But here, just to correct the question, okay, we should write here one after the other. We are picking up the beans, okay, one after the other, right here. So one after the other, first one is green, and then second one is also green. So 5 divided by 25 and 5 divided by 25. So this is what you should remember, otherwise it is confusing. Are we picking up the jelly beans together, both the jelly beans we are picking up together, or one after the other, right? So that could be this is what the main thing you have here, right? Let's come to the next question. My sock drawer has 5 red socks and 4 blue socks. Okay, if I randomly pick up 2 socks, what is the probability that I'll have a pair of blue socks? Okay, 5 red. So, okay, now red 1, red 2, red 3, red 4. Okay, let me do it on the next page. I have 5 red and okay, and we are picking up 2. Okay, let's do here. Second question here. 5 red. This is our drawer, let's say. So red 1, red 2, red 3, red 4, red 5, and blue 1, B1, B2, B3, B4. Now, how many total cases are there? B1 can be combination with anything, any other one, right? So it is what? 20 cases, because 4 into 5, 20. Now I want both to be what? I'll have the pair of blue socks. Okay, I want the pair of blue socks. So B with another one, right? Now B1 can have B2, B1 can make pair with B3, B3 can, okay, B1 can make B4 also. Now B2, B3 could also be there, and B3, B4 could be there. So what is the answer here we're getting? Okay, once again, B1, B2, okay, B2, B3, and yeah, I think one more, B2, B4, that also could be there, right? So 6 divided by, so it should be, okay, here, okay, why answers are completely different? Because this is what answer should be here. I think there is some mismatch here. Okay, fine, no problem. Okay, this is what it is. 6, because 6 combination could be there. Both the blue we want, right? We want both blue only there. Okay. Okay, don't worry. We will. I hope you understood the concept. We'll verify the answers. Okay, but I think you are getting it. Okay, this is how we can do. Now, if again one after the other we are picking, it could be confusing again that way, right? So that's why here, this is what it is happening. Okay, like here, it could be like confusing that way, right? Okay, if we are picking up one after the other, then it is completely different scenario. Now, if I say here one after the other, we are picking up, right? So it will be again, okay, like that is what in the question it should be mentioned. Otherwise, it is not proper question. But you don't worry, you can make this way combination. Or one after the other means what? Okay, we want first one to be blue, so 4 by 9, and then second one also to be blue. So how many? First blue is gone, so 3 by what it will be? 3 by 8, right? So we can have here 3 threes are 9 and 4 twos are 8. So this is how they are giving the answer 1 by 6, right? Now this is what the problem with these questions. Okay, if we are picking, what is the probability that I'll have the pair of blue socks? Okay, both I am randomly picking up two socks. Okay, one after the other. If we're picking, okay, so this is what it is, right? So in the previous question also we are picking up, okay, right? So this is what the correction we need to make, guys. Okay, I'm so sorry for that. Okay, this is what 5 divided by 25. Yeah, we didn't see that. Okay, like we are not replacing it back, right? This jelly beans, we are not replacing back. So 5 divided by 25. Now here 4. We want both green. So 4 divided by what it is? 24, right? So this should be the correct answer. Yes, right. Okay, 5 fives are and 4 sixes are. So we get 1 by 30, right? So please correct the answer. Okay, I know this is what, so they are just telling here one after the other only, right? One after the other we need to pick the jelly beans also, and then this one also here. So just don't take, as of now you do, they should mention this, that one after the other we are picking up, right? So this should not be there at all, right? So this case we need to remove from here, right? Now a dart is tossed and hits the dart. Okay, this is what geometry related problem. Okay, so let's do this because that is what main topic we are doing today, right? A dart is tossed and hits the dart board shown below. The dart is equally likely to land on the point on the dartboard. Find the probability that the dart lands in the red region, right? Red region. So now let's do it here only. Now red region we want to, it has to land. So what is the area? You can see here area, because it is area problem here. So we can say here pi r square. Area of the red region is what? Pi r square. So 2 square divided by total area is what? 16 into 16. So it will be what? Right. Okay, this is what, find the that it lies hits the dart board shown below. The dart is equally likely to land on the point on the dartboard. Find the probability that dart lands in the red region. Yeah, so it should be pi divided by 4 fours are 64. We need to give the answer, this one. Right, I hope you're getting it. Okay, this is what we need to do. Now again in this question there are two regions. Okay, they didn't mention this. Okay, so this is what we need to have. Any point on the dartboard. Okay, so that's why any point, this full is what? Dartboard, so we need to take full area only. Any point they said. If they're talking about red and any point on the dartboard means red and yellow part, so then we need to give different answer, but here this is what the answer we need to give. I know, again they wrote this answer here like that. Okay, so okay, like, okay, first answer I can understand, right? First two answers I can understand, they are doing in that way, so it is fine. This is 1 by 30 only, right? But the last answer, again this is not clear, so this is what we need to understand it this way, right? But let me take one more question here to make it should not be confusing for you. Suppose I say there is a cube, there is a okay, it is cube, assume it to be cube, right? There is a cube of side length a, and now I want to cut out, right? I want to cut out the portion, okay, maximum portion of the, like, sphere portion I want to cut out. So probability that a particular point, which is what, a particular particle of this box, okay, let's say it is solid box, okay, so particular point will come out in that circular part or will not come. What is the probability of that? So volume of sphere divided by volume of uh, full cube, right? We need to write, so volume of sphere will be what, 4 by 3 pi. And what is the maximum? We are saying maximum volume, so maximum means what is the radius it is going to have? A by 2 cube. Now what is the volume of cube here? A cube. So a will get cancelled out, and we will get, what is the answer we are getting? It is 8 here, so 1 by 6, pi by 6, right? We are getting pi by 6 as the answer, right? I hope you're understanding this. I know you can try questions from the module and all, okay, from different book, and let's see, right? This is what easy topic, not that confusing. Don't worry about it, okay? Question will be given in proper format. You don't need to worry about this here. This confusion should not be there at all, right? So okay, let's end the lecture here, right? I hope you got the idea. You can practice more questions to understand it clearly. Okay, thank you very much for your time. Thank you.